Okay, so you can see that I skipped to chapter 5 with the lecture slides, and this has to do with the charts. So recall that I said that the levels of measurement will determine which chart that you'll use and which analysis and the corresponding chart that you'll use with that to display the data. So when we're looking at univariate data, just one at a time, so when we looked at nominal level in the earlier slides, then ordinal, and then interval, that's what I'm referring to. So typically in practice, folks will use a pie chart when displaying visually the results of their analysis with a variable that is nominal level. So for instance, here it says genre of movie, the favorite genre of movie. Um, you can see that each of these slices uh, represent a level of that variable. So it says independent, indie. This yellow is for comedy, drama is this shade here, and the dark blue goes to this level or this category here, action, documentary, and then horror. All right, and then what corresponds to the shape or the size of the pie will be the percentage or the relative frequency, or sometimes you can display it in the absolute in terms of just what is the frequency. So let's say 17 people liked action movies or whatever, or comedies. It'll have the exact number there instead of the percentage. Okay. So nominal is just right for this to use this chart. And then also you can use ordinal, but I think folks visually can interpret if there's just a difference, just so they can see how what the frequencies are and how it's laid out. This is just fine, but for ordinal, it's fine as well. But typically folks use what's called the bar graph, and you can see that these are bars. Looking at the percentage, this is relative frequency, so you can even have just exactly what the number is here, or the absolute frequency. And then these are the different levels of the variable highest level of education that someone obtained. So bachelor's, some master's, and some doctoral. And you see that they don't touch. Remember when we said that ordinal, it tells which is higher or lower, but you can't tell what is in between these two levels. Okay, so you can't either have a bachelor's, and what's more than that is some masters and then a master's. But in between some masters and bachelors, you don't know what that is. It's not some masters or bachelors, some they didn't give it a category. It's just something in between that. Same thing, some masters and masters, we don't know what that is. Okay, so they never touch. So even if you said select one and you had 1 bachelor's, 2 some masters, 3 masters, and then 4 some doctoral, and a number of folks circled 2 for some masters, it doesn't mean that you're going to calculate what that 2 and 1 and 3 and 4 are. It's nothing you can do with that. We just are looking at, in terms of frequency, how many people said 2, how many people said 3 masters, how many people said 4 some doctoral. Okay, and just go and read what the definition for bar graph is. You can look for the bar graphs. You can also use the nominal level and to display it, and folks will be fine with that. So the pie chart or the bar chart, you can use nominal level or ordinal. And I paused because I have an issue with this, and I know that I gave credit for it, and that's fine. But really in practice, either interval or ratio level Um, use interval ratio to use the histogram to display your interval or your ratio level. I rarely see ordinal displayed with a histogram, and so at this point, I don't think you should take part in that. Uh, the picture did not come up, but it looks just like a bar graph, but except for the bars will actually touch each other. Okay, so if you're looking at age again, I gave that example earlier. You know that if someone is 22, they are exactly 2 years younger than someone who was 24. Okay, and so even the next person may be 23. You may have folks who they're 19, but you could tell if they're higher or lower than the next person, and then by how much they're younger or older or higher or lower. Okay, I hope that makes sense. All right, so and then we have a number of other graphs, but the main ones are pie, bar, and histogram. Okay. Okay, so you'll see that I skipped to measures of central tendency, and again, depending on if it's nominal, ordinal, or integral, that will determine how you talk about, on average, where your data lie, and or describing your data. Um, in addition, we have something else called dispersion to show the spread. But for now, if you're talking in terms of uh, just simply, and you can certainly read more in your text, but if you're looking at a nominal level variable, if you want to describe it, there is no way that you can give a mean of, say, something like race. You can't give a mean of race. Um, it's not tied to, or you can't relate it to numbers. So that would not make um, sense to try to describe it using a mean. A mean is just the average of the numbers. So same thing with ordinal. You wouldn't get a mean of ordinal level data. You would only get the mean for interval level or ratio data. Numbers. You can only get the mean for numbers. So on average, what does the data look like? Median, you can use the median for ordinal level data, and that's just saying what is the middling point. So in the middle, how does it balance out? What is the middle on average in relation to your variable? So if you're talking about level of satisfaction, just typically, how are people responding about that? So if you surveyed 500 folks, typically out of 1, 2, 3, 4, very dissatisfied, uh, satisfied, and very satisfied, um, what is the median? Um, what's in the middle? Okay, and the last one is nominal mode. That's just what is the most frequent. What is the most frequent value? So when I mentioned race before, that we can't get a mean of race, this would be most appropriate to use the mode. And there's a little bit more information in your text if you want to read on there. Okay, so I skipped to distributions, and I just wanted to preface our conversation about the relationship between two variables and inferential statistics when we're looking at what is the relationship between the independent variable and the dependent variable. Let me just give you the background. So when you have a sample, it's just part of the population that you're interested in studying, and it's sometimes just more realistic to study a smaller subset of the grander or the greater population. Um, it would be unrealistic to think you can survey every single person if you're interested in folks in the United States. everyone in the US. So it's better to get like a representative sample so that you can conduct your study. So I just wanted to point that out. The purpose of inferential analysis or statistics is so that you can make inferences, draw it from this small sample, um, relatively small sample, and then generalize to the greater population. Like say, it worked here and this is what's going on. These are related with this small sample. So then, therefore, we can say the greater population is most likely experiencing this. They may behave this way in a similar way or have the same attitude and so forth. All right, so it has to do with probability sampling. And in order to get that um, in the best case scenario, you would have to have random sampling so that you can avoid bias, anything that might um, affect negatively or adversely affect your results that didn't have anything to do with your intent. So sampling error occurs when statistical characteristics of the population are estimated from the subset or sample of that population. And I'll demonstrate. If you guys were there when we did the McDonald's example, that was just perfect. But I'll see if we can't get a little bit more information in just a second. Okay, so this is perfect. Just continue along in your slides and it gives you a little bit more information. And so when we're looking at the p-value for any of these analyses, if we're wanting to hypothesize about the relationships between your independent variable and your dependent variable, for instance, if we think that more males will have a higher salary than females, we're looking at the relationship between gender and salary. All right. And so that's the first step when we run our analysis, when we conduct the study, then look at those numbers. Say we use the means comparison test, a t-test, since we only have two categories under the independent variable. Recall that we touched on that. If we were going to use a t-test to analyze the relationship between those variables, independent variable is nominal with two categories, and the second variable, your dependent variable, is interval. We would use a t-test to compare the means. So in testing whether or not those two variables are related, the first step is make sure that the results are in the direction of what we predicted. So when it comes back and it shows the mean for men being 50,000 and the mean for women being 40,000, then that's indicative of the results being in the direction of what we predicted. We said that we believe that men will have a higher salary, and we can base that on a number of things: practice, experience, society, different things. And so when we look at that in the analysis, the results will show us the mean for men and the mean for women. And when we see that higher salary for men, we could say, yes, so far I have support for my hypothesis. Step one, the results are in the direction that I predicted. And then step two, we need to look at what's called the p-value, or the probability and probability level value. And so what we're looking for is not to have too much error. And it's wonderful if we don't have any error at all. Okay, sampling error. So in a sense, it's saying that if we, by conventional standards, by the way, for social work, psychology, HDFS, any of the social sciences, it's acceptable to have a p-value of 0.05 or less for us to say, yes, it's in the direction of what we predicted. So if our p-value is 0.05 or less, then we have support for our hypothesis, and we can reject the null hypothesis that there is no relationship. So we want it to be a relationship, and that's a wonderful thing if the p-value is 0.05, not 0.5, but 0.05 or less. So 0.000 is wonderful. I'll continue in a minute.